Welcome back, class. Thanks for tuning in. We're going to be going into week 8, part 1 here, and we're going to be doing matrix multiplication or products of matrices, not just scalar, but also multiple matrices where you're going to multiply them together. And it could be a string of 2 of them. It could be different sizes, not just the same size like we did last week. And this will take us into our last week's material next week, which is solving systems using them. So hopefully this makes sense to you. This is something that I think is going to gradually progress, and you'll see kind of the importance of what a matrix can do. But yeah, let's jump right in. Let's take a look, and let's go right to the iPad. Here. So what you're looking at here on my iPad is the topic this week, which is matrix multiplication, the products of matrices. Again, I'm still using that same diagram where we have to look at rows and columns. That dimension of a product or of a matrix is super important. So when we look at multiplying matrices, we do have to know the dimensions. That little number there in that corner, 1 by 2. So that's something we're going to be looking at. But let's jump right in. What we have here is a matrix. Now, obviously, this matrix is a 2 by 3. Now, again, the big purpose of this is just knowing how many rows you have and how many columns you have. That's why I put this up here. I almost spelled columns wrong. The idea is that we need to know that. If you can't figure out those numbers, it's going to be pretty hard to figure out matrix multiplication because you have to check dimensions and see if it's going to work out. But now, if we're going to do scalar multiplication, so let's say I'm going to multiply by a number out front. Let's say I'm going to multiply everything by a 5. We can instantly do that. Scalar multiplication, when you just have numbers out front of matrices, you just multiply every matrix or every entry in that matrix by that number. So we're going to get a 30, we'll get a 20, 24 by times 5 is a 0, carry a 2, that's 120. That's a 5, that's a negative 45, and 8 times 5 is 40. So, all right, there you go. Again, I better check to see. Let's double check my math here and let's see if I'm actually correct with that. What are we at? 24 times 5? 24 times 5? Yeah, 120. Okay, so I was right. Perfect. Okay, I just want to check that real quick. Okay, so that's the first step. Scalar multiplication, pretty easy. You can scale anything up, change the size of anything. So let's go into matrix multiplication. We have 2 different matrices. These are matrices. And they're different sizes. That first one is 3 rows by 1 column. This next one is 1 row by 3 columns. So the idea here is that can we multiply these together? And the check that we do is we do this. You look at the middle numbers that are closest together. These numbers tell you if you can actually multiply these 2 matrices together. In my case, yes. These numbers match, the 1 and 1. Those match, and so you can actually multiply these. That's the only check we have. And the result of this matrix will be the outside number. So this matrix, believe it or not, is going to be 3 by 3. It's the outside numbers. This is pretty big. I know I'm getting blocked up by that little camera there. I can go directly to the iPad if I need to. But let's go through this. So again, it's row by column. So row by column. So this first entry in the upper left corner, row and column. So row is 4 times 1. That number goes here. So it's just 4. Then I do it again. Row by column. So 4 times 2. And then row by column. So 4 times 3. That number goes there. Again, I'm on the first row, just doing each column separately. Now I'm going on to the second row, and I'll switch at colors here. Second row, first column. So I go 5 times 1. Second row, second column, 5 times 2. And then 5 times 3. So you do the last one. Alright, and we go to the next one. So now we're going on to, I'll switch at colors again. So we're going to go 6 times 1, and 6 times 2, and we have 6 times 3. Yeah, it looks like you guys can see it. Kind of check my monitor to see how well you guys can see that. Okay, and so those would be each of the numbers. So it ended up being a 3 by 3 matrix. Again, row by column, row by column. Let's go to the next one here. I only got a select few problems picked out. Let's take a look at the dimensions here. So this first matrix is a 1 row by 3 columns. Or, yeah, 3 columns. And then the second one is 3 rows by 1 column. And so we look at the middle numbers, and we do have 3's there that match. So we can multiply these together. And my final matrix, believe it or not, it's going to seem a little silly, my final matrix will be a 1 by 1 matrix. Those are the outside numbers. So it's just going to be one entry, one number. It's going to be one digit. So row by column. That's how we do it. So first row, first column. Second row, first column. Third row, or third column. And third row. All right, there we go. And we add these together because, again, it's the whole row by the whole column, entry for entry, and you add those all up. Because that's how it works when you actually have multiple things in that column. So kind of interesting how that worked, and it actually ended up being a kind of a weird number. We had what is that? 18 plus 10 plus 4. And that would be the one number that sits in that matrix. So it's a one-digit matrix. Kind of an interesting concept. Now notice, if you look back to the last problem I did and this problem, these were the same matrices. I just flip-flopped them, and they give me completely different answers. That's how it works. I kind of give you that concept last week when we were subtracting matrices, that you had to be careful about how you subtracted them, because the order of the matrices matter, because you're going to have to subtract the second one. It matters when you multiply. As you can tell here, these matrices were completely different in size. So think about that concept. All right, so now we're getting to more traditional. I think I got 2 of these picked out. And I think it's the same matrix, I just kind of flip-flopped them. Okay, so what we're going to have is we have a 2 by 2 matrix and a 2 by 2. So obviously the middle numbers match, so you can actually multiply these together. It's going to end up being the outside digits on that dimension, so it's going to be a 2 by 2. Again, if my camera gets in the way, I'll get rid of the camera here. So what we have is first row, first column, 2 times 1, and 0 times 3. There's the first one. And then first row, second column, so 2 times the 2, and the 0 times 4. There we go. Wouldn't let me write the plus sign. So again, first row, first column, and then first row, second column. There you go. And now we go to the second one. So I'm going to flip the colors here. So we have the 1 times the first column, and the 2 times this first column. There we go. And then the first... so now second row, second column. So 1 times the 2, and the 2 times the 4. There we go. So 1 times the 2 and 2 times the 4, yeah. So there you go. So it ended up being a 2 by 2. Alright, let's go to the next one. Now we can get those answers. This is the same matrix. I just flip-flopped them. So you can, if you went back and you paused that last part and you kind of figure out what the numbers were going to be, this matrix could have different digits. Because again, first row, first column, so 1 times 2, and 2 times the 1. So 1 times 2 and 2 times 1. And then first row, second column now, so it's 1 times the 0, and the 2 times the 2. 2 times the 2, if it allows me to write that way. That's it. There's a dead spot on the iPad. Now, we're going on the second row, so 3 times the 2, and the 4 times the 1. So again, it's the second row, first column, and now second row times the last column. Again, it's always row and columns. So there you go, and you can figure out the numbers there. And the absolute last problem here, you get a weird looking matrix. This first one is 2 by 3, 2 rows, 3 columns. This next one is 3 columns and 2 rows. 3 rows, 2 columns. Geez. And so we check the middle numbers match, and my final answer will be a 2 by 2 matrix, because those are the outside digits. The middle numbers, when you check the dimensions, have to match for you to multiply. So again, first row, first column, 1 times the 7, the 2 times the 9, the 3 times the 11. Okay, flip up the colors here. First row, second column. 1 times 8, 2 times 10, and 3 times 12. So again, first row, second column. Now we're going on the bottom. So second row, first column. 4 times the 7, the 5 times the 9, the 6 times the 11. Now second row, second column now. 4 times the 8, the 5 times the 10, and the last number is 6 times the 12. So again, row, column. Now, obviously that was our kind of our last problem there. Thank you for all those who are still participating. Maybe you're not submitting the forms online, maybe just try them on paper to see if you can do it. But again, I appreciate it. Next week's topic will be the last topic of the year. It'll be doing systems with matrices, so solving a system. And we have 2 equations, or maybe even they have 3 dimensions, maybe, where they're crossing, and you're trying to figure out the one solution that works for both. But it's using matrices, so it's called reduced row echelon form. They're using kind of some interesting concepts to solve. It's based on elimination method, but it's kind of an interesting concept, and so hopefully you'll stick around for that. But again, I hope to see you guys real soon. Take care of each other and stay healthy. See you real soon. Bye.